So it should be recorded. So again, first theorem we learned that was unique to a rhombus is that the diagonals are perpendicular. And that's the main one, because again, today we're going to learn another shape where the diagonals are also perpendicular. Yeah, laptops out. But we do need pages out. Everybody should have pages out. Oh, pages out. So we get a folder. What's the so now on Israel. Israel, what's the other one? So actually the other shape we're learning also has that in common with a rhombus. So that has they have two traits in common. So for the diagonals, again, still talking about the diagonals of a rhombus, the diagonals bisect the angles. The angles. So you could say that, the diagonals are angle bisectors. Done angle bisectors before, saying the same thing. So you need to understand that when we have diagonals drawn into a rhombus, that we are going to have two smaller angles created that are congruent. You'll see, or you'll need to put in the congruence marks for those two smaller angles, and then those will equal the angles across, because for a rhombus, opposite angles are congruent. So if we split those angles in half, then all four of the little angles are going to be. So we went over all of that. That's nothing new. If you did not do well on this quiz, though, that's the kind of stuff you'll need to know. There are. Let's see if I can do this. Well, messing up my report. Oh yeah. So there are IXLs on rhombuses in there. A lot of you are going to need to practice for your next retake, whether it be practice on your own or if you owe me tutoring. If you're doing tutoring, this is going to be broken into 2 grades. This most recent one, I haven't graded or anything yet, so you don't know yet what you have. But you'll owe me 30 minutes for each grade for these 2 over here. So for you got a deadline this Friday for the one from before break. I'm letting you do a 30 minutes on that one just because it was before break, and I don't think that many people are going to retake it anyway. It's a much tougher quiz, and the people that have retaken it haven't done very well on it, so I don't think they'll improve. The angles and polygons with only 4 questions, so you can just do 30 minutes on that. So far every grade is 30 minutes of tutoring. So if you got a 40, then you owe me 30 minutes for any one of those individually. And then I'll break this quiz up that you just took into 2 grades, and you'll owe me 30 for the individual parts of that. So I'll talk more about that once I get to it. But there are IXLs in here. So I've got tons of IXLs. If you just want a general practice, that's on all quadrilaterals, which is what the whole chapter was on, the whole module. We're going to get to kites today, kites and trapezoids, so you'll have some IXLs for that. We've already done squares and rectangles. You got one for that. Rhombuses. Some of that stuff in there is just understanding the theorems about them. Some of it is solving. So you got a little bit of everything. I think there's proving a quadrilateral is a parallelogram. That was on the quiz you just took on Monday. Classifying has to do with just recognizing them. I'm not doing a lot with that. I probably should, because I think there was some stuff on the I guess it would be the final exam, the EOC last year, where you had to just be able to know what the shape was by looking at it. I haven't really spent a lot of time with that and making that a big deal, but finding missing angles in quadrilaterals, you definitely need to know how to do that. Properties, I mean, all that stuff is good. So when you go into, it's the last 10 to 12 or whatever IXLs that I'm assuming it orders them the same way it orders them for me. So you got plenty of stuff you can practice. And obviously you can do the book pages, which is all right here. Thank you. All right, back to today. Get your pages out if you didn't already get your pages out. So we're done with rhombus. We're moving into trapezoids and chiral. Again, other shapes, different theorems, different properties. The more you understand, like the more you get concepts, or just kind of maybe even can use a little bit of your logical reasoning, your geometric reasoning, the less you'll have to memorize theorems. But if you don't get it, you can get by memory. Some of this stuff, the math is just based on memorizing a theorem if you don't get the concept. All right. So first thing you need to know is for a trapezoid. It's not a parallelogram. So that's the first thing you may want to jot down. Not a parallelogram. One pair of sides is one pair of opposite sides is parallel. So we have top and bottom parallel, but not left and right. Or it could be the other way around, left and right are parallel, but not top and bottom. So exactly one pair. If there was two pairs, it'd be a parallel. It's not parallel. So again, top and bottom or left and right can be parallel, but then not the other opposite sides. So the two sides that are parallel are called these bases. Now I'll use these terms a lot, so I'm not going to give you a definitions quiz, but I'm going to refer to it. And if you have no idea what I'm talking about, you're going to have no clue on how to follow and do the problems. So when I say base, it means, or bases plural, it means the parallel sides for a trapezoid. If I say leg, which we've used that before in other shapes, legs are the sides that are not parallel. And again, this is all in your book. I took this straight from your book. You should kind of recognize the way it looks. There we go. Let's see. So base angles. They explain it a little differently. I just say the base angles are like, let me see how they explain. Yeah, they say it's formed by a base and a leg. That's what they say. I just say it's the angles, like where the base, like if this is my base, the angles of the base, and they would be different measures. They wouldn't be the same, but I mean they are formed. You see that I'm using a leg also, like a leg and the base, a leg and a base. I mean they're just the two angles. Well, actually four angles, because I would also have base angles up here. Those are also base angles, because again, they're formed with a base, the base on the top. So there's four base angles. Make sure you understand that. Two bases, four base angles. Two legs, still four base angles. So here's the big one that allows you to do extra math. This is one you got to know. So make sure you highlight that. However you highlight, underline, if you actually have highlighter, highlight it. That's the one that allows you to do the most math. There's not a whole lot you can really do with just a generic trapezoid. If you'll notice, there are no theorems at all that just say trapezoid. The only theorems say isosceles trapezoid. That's really the only one that has special properties that would allow us to, just by knowing the name of the figure, that would allow us to then make some other conclusions. About the old, tell me one thing we can say about this figure, and I'll even be more specific, the angles of that figure. There is one thing we can say. But normally they will be different. They don't have to be, but normally they will be. Actually, maybe they do have to be all different. I think they do have to be. Otherwise, it would be an isosceles trapezoid. If two of them are the same, then they're all different. We can have a right angle actually in an array. That one doesn't, but we could. You could have, so this that, well, the top and the bottom would be parallel. That wasn't a very good job of making it parallel, but that angle right here could be a right angle. Still meets all the criteria. But could actually have a right angle. What can you tell me about the interior angles of that? I'll give you a hint. It has nothing to do with trapezoids. It has to do with old lesson. Yeah, don't forget the old stuff because that will come back into play. If we have a four-sided figure, number of sides subtract 2 times 180 gives me the total, the sum of the interior. Or you just remember we said every four-sided figure is at 360 degrees in the interior. This 4 subtract 2 is 2. 2 times 180 is 360. So don't forget that old stuff. All right, so let's go to the isosceles trapezoid, since that's the one that's going to have the problems associated with it. Let's see. I'll go over each. I was going to say, I'm just going to give you a general lesson, but we'll go over the specific theorem. So, all right, so first one said trapezoid is isosceles and each pair of base angles is congruent. So what that means, as you can see in the markings, the base angles are what? What did we say? Where did I leave off that? Tarvis, you came in late. Jamarcus, what are the base angles? What did I say definition of base angle is? That's the parallel side, so it'd be the angles at the ends of the base or at the ends of the base up top. So the base angles are going to be congruent. So again, those two are congruent to each other. These two are congruent to each other. That's the first thing about an isosceles triangle. That's a big. Let me zoom in. Oh wait, I have a new button. I added a new button. Right? There we go. That's there. We go. All right. So again, they're not all four congruent to each other. Make sure you understand that. The two angles at the ends of the base are congruent, and then the two angles at the bottom. And they will never actually all four be congruent because then it'd be a different shape. It's square or rectangle. All right. The next thing is this. The legs are congruent. Same length. Again, top and bottom or the parallel sides will never be congruent because then it would have to be a different shape in order for that to happen. Here, really have to be a rectangle. If the legs are also. So again, that's the other big thing. So that's your first theorem. Angles, base angles congruent on top and bottom or left and right, depending on which sides are parallel, and the legs are congruent. And that's going to allow you, as soon as they say isosceles trapezoid, to now do a lot of math that you wouldn't be able to do on a regular trapezoid. So next, trapezoid has one pair of congruent base angles, then it is isosceles. One pair of congruent base angles. So all that, I'm not sure why they gave you this. So ignore that. So this would not be in there. I don't know why they told you. So if we have a trapezoid, so again, this would be the way this problem would go. Something like this. I would not tell you. Would have to tell you they're at least parallel. I would tell you they're parallel. I would not tell you that these lines are congruent. That would not be in there, so I'm not sure why they put them in there on that one. All I would say is that's congruent to that. I wouldn't even tell you the top two are congruent. Just from two things, you should be able to say, yeah, that's isosceles. It goes back to the same lesson that a lot of the other stuff went back to when we had parallel lines. When I have parallel lines, it's going to create a lot of congruent angles. We could go through and prove Well, if we know these are parallel, and I know I have that crossing through, I can wind up proving that that is congruent to that out here, which I do the same thing over here. And then that winds up being able to prove that those top two are also. I'm not going to go through proofs. You're certainly not going to have to do any proof stuff, but you need to understand that even if you just think about it visually, like if these two angles are coming up at the same angle, because again, we said these are congruent, if they're coming up or coming out at the same angle, and these lines are parallel, like parallel lines are always going to create same angles. But if you just write that down, parallel lines create same angles. That's not 100% of the time because I can't say these two are congruent. So be a little careful about it. But just if you just have that in the back of your mind when you're dealing with parallel lines, you're going to get a lot of congruent angles. And from there, you can hopefully figure out which ones are congruent and which ones are not. And you'll still get a lot of angles that add up to 180 as well, which might even be the next theorem. I don't know. But you'll notice opposite angles are not congruent. This is not a parallelogram. Not the opposite ones that are congruent. It's the ones kind of on the same side over here that are congruent. Same side being the parallel side. So those are congruent there. And that would mean these are also congruent. And because we know now we know it's an isosceles triangle, if we know one pair of angles is congruent, and we have two parallel lines, we can now say, well, that means these sides are the same length also. So that's where your math is going to come from. I'm going to give you one little piece, which would, well, two pieces technically, which would be this and this, and this and this. That's all I'll give you. And you need to know the other piece. You would need to know those are congruent and those are congruent. That's the connection you're going to have to make. All right, next one. I think it's the last one. Trapezoid is isosceles if and only if diagonals are congruent. All right, so if we have, again, you have to be told that because we have to know it's a trapezoid to start with. So we have to have one pair of parallel sides. Why it's, I don't know why they're doing the markings the way they're doing it again. So that you wouldn't know that. That's the conclusion you would have to make if I tell you RT, so that's a diagonal, is equal to, or I could say congruent to QS. So that would be the only two things you would get on the problem. You now have to understand, well, if that's true, if my diagonals are congruent, and I have to know that there's at least, well, there's exactly, not at least, exactly one pair of parallel lines. Now that should be enough for you to say, okay, I know that's got to be a trapezoid. That I would say is probably the trickier one out of all. Especially in that figure, it doesn't, like, I don't know if that's drawn to scale or not, but to me, that doesn't look like it's nice and symmetrical. The left and the right side don't look like they're congruent to me. The diagonals don't look like they're congruent to me. So you would just have to go based on the given information and just, again, don't worry about the way the picture looks. So two things are given, parallel lines, and then QS is congruent to RT. And then that means if the diagonals are congruent, that means it has to be, and that would come back to our congruent triangle stuff. We could prove because of the parallel lines, and if we draw in one diagonal, we can wind up proving that we have some congruent triangles. Actually, I have to draw in both diagonals to prove some of the congruent stuff. But again, it would come all the way back to parallel lines and a transversal and being able to prove that you have some congruent triangles in there. If we have time, I might show that another day, but I'm not worried about it today. For now, those are the three you need to know about trapezoids. Any questions on any of those? And the less you are intuitively just understanding, the more you got to memorize those. And you got a lot of other ones, a lot of other shapes that we've done that also continue to remember. All right, so this is example one. So look at example one. I want you to don't use the book pages yet. If you have a notebook, you can do it in your notebook first. If you only have the book pages out, just do it in the margin. Don't read, because again, they've solved it for you in the book. I want you to just look at what I have. I think that's all you need. Oh, wait, we're proving there. You need that piece. We are proving X. Oh, yeah, up here. So we're proving X equals 11. That just means you're solving out for X. And when you solve out, you should get 11. That's all all proving X is 11 means. They're telling you it's an isosceles trapezoid. So you know 3 theorems now that you should be able to use. I'm going to make you pick the correct theorem. So try to set up an equation and solve out. I'll give you a hint in like a minute so that you're not just sitting there stuck. And then gradually we'll work our way into the equation. And then from there, you need to certainly be able to finish the algebra. So the figure is A, B, C, D right here. It is an isosceles trapezoid. They just tell you that in this one. So you should now know everything that's equal. The hardest part about this one's the algebra. Oh, I know what I want to tell you. Let me do a 10 real quick. Ah, all right. So if it is an isosceles triangle, which theorem do you need in this one? What's the important theorem for this one? Where I leave off. All right. So Adam, what's the important theorem? Well, what kind of trapezoid? Yeah, just trapezoid. Remember, there's nothing you other than knowing that the interior angles add up to 360. There's nothing you can do with just a generic trapezoid. It has to be isosceles to really be able to do much with it. So there were 3 theorems for isosceles trapezoid. Which one do you think this is about? That's a problem, huh? What are these expressions about? 3x subtract 2, 3x plus 9. What's that about? There's one thing you should know immediately. I gave you a hint when I wrote it up on the board, so I wanted to talk about it. Why did I write this? Why did I write that? What is that? It is a degree symbol, right? Is that in any of those expressions? So what are those expressions about? Length of side. Way too many people took more than one problem on the last quiz that didn't have a degree symbol in it, meaning they were about lengths, and set it equal to 180 or 360 or some other number that is about degrees. Way too many people. That is lack of effort, period. There's, all you got to remember is there's no degree symbol, it's about length. And you should know if it's about length, it can't be about 180. 180 is degrees, 360 is degrees, 90 degrees. Like all those numbers are about degrees. You don't know anything about length. Length could be any number in the world. So that is, I don't know how many times I've said that in class, a lot. That is you not putting the effort in. And that's how I know when I'm grading quizzes, that you're not putting the effort in. There's stuff like that. I get that you're not going to understand everything. Concepts can be tough. Algebra can be tough on some problems. That's none of that. That's effort. So if you're not putting the effort in, it tells me a lot about what your understanding is. So it's going to be really tough to do poorly on those little things and then somehow do well. So show me care. All right, so these are about length. So what do we know about length? Which theorem is about length? For an isosceles trapezoid. Or there might have been one that was about both. I don't know. But you're looking for something about length of sides in there. So Chloe. That's like she's up. She's up. In your book, find it. One of them is about length of side, or just about length of side. We'll look at it in a minute. Which theorem? We learned 3 new theorems about an isosceles trapezoid. Which theorem is about length of sides? Exactly what you'll need to do when you practice on your own. Is go back to the theorems, figure out which one you use for whatever problem you're doing. Read them. Got to be one. I don't know. I really don't know. One of them got to say something about length of sides or sides being equal or something like that. They all have congruent marks, so you can't just use that. I don't know, and I don't know why they did that. Fine. Does everybody agree with that? Which one did you say? 1.22, is that the one that says something about length of sides? We think so. We need to look at it. I really don't have it memorized or anything. I know what the properties are. Let's see. So 2-1. Yeah, that's just about base angles. So it's not 2-1. There's one pair of congruent base angles. Well, no, that's about angles. Oh, actually, none of them. So I guess that's just a definition. So I thought that was a theorem. So technically, it's not a theorem. So that's just the definition. So if they tell you that it's isosceles, you just have to know that the sides, the legs, yeah, that was in the definition now. Oh yeah, legs are congruent. So they just tell you in the definition. So I guess that's not a theorem. So all the theorems just allow you to determine from the angles it looks like that it's isosceles, and then you have to know that the definition of an isosceles trapezoid is that the legs are the same length. All right, so that's just a definition. So if we know the legs are the same length, on to Leslie, which sides, you have 4 options. Which sides are the legs? You have DA or AD, CB, DC, and AB. Which sides are the legs? Give you a hint. Raising your hand, Rihanna, or are you fixing? So again, the legs would be the sides that are congruent. Does AB look like it's congruent to DC? Well, no, I'm asking her a question. Because again, the legs are congruent. That's the congruent side.
Says the parallel sides are called the legs.
Right. So you don't think AB and DC are parallel? What's parallel mean? Let's talk about that. What's parallel mean? Anybody can answer this. They will never touch, right? If they went on forever, they would never touch. If I choose AB and DC, those don't look like they're going to touch to me. Those are the parallel sides. The legs are not. So write this note. I don't think it specifically says this. The legs are the sides that are not parallel. Legs are not parallel. That helps you. Again, maybe it says it in there. I don't know exactly what it says. The bases are parallel. If you need to specifically write out, no phone, Jarvis. You wrote that the legs are not parallel? Well, then if you know that, then in order to find the legs, which sides are not parallel? Which sides would eventually hit each other? Because again, remember that you got to imagine they go on forever. Which sides would eventually connect, eventually hit somewhere way off the screen? Let me ask you this. If this line keeps going, that line keeps going, and it look like those are going to hit, those are the legs. Whichever two sides look like they will eventually hit, those are the legs. And now that we know where the legs are, it's the legs that are equal. The legs are congruent. So I know, and I would write it like this personally. You don't have to. I'll do it here. I would say, okay, well, then I know AD is a leg. I know the legs are congruent. So I'd write that. I would write again, baby steps, write what you know. Don't immediately try to jump into solving. Do what you know. Well, I know for an isosceles triangle, the legs are congruent. And I know now that those are the two legs because they would eventually hit. The legs will eventually hit. They're not parallel. Now I just need to substitute in, well, what does AD equal? And again, not a number, just those expressions are the lengths of the sides. So what does AD equal, Jordan? AD. It's in the given information. Yeah, this is, so again, you need to always do this. That is the length. That is the length. That is the length. That is the length. Doesn't matter what's in those circles. Those are the lengths of the sides. Number one. You talking about example? Oh, I'm not following that. We're not doing the proof on it. We're just solving. Yeah, all you're doing is solving the equation. I think they're treating it like a proof because they say prove. Rihanna, is that what you were waiting on, or were you answering the question? She had her hand up, so here you can go ahead and start that. I'm not having to write a name, probably since you should straighten it back and they don't really check. So if I know what so again, don't worry about the proofs. I'm not going to make you do proof. I'll just give you a problem where you just solve for X, which is the same thing you're doing in the proof. So AD, we said, is 4X plus 5. Well, what is CB equal to, Alyssa? Oh, actually, I was like, where is it? Oh, they actually wrote it as BC. So same thing, that you can flip the letters. So CB or BC is the way they wrote it. 5X subtract 6. If you can say it in words, AD is the same length as CB. the word is means equals. Change is to equals. And then you just change AD to whatever AD equals. And you change BC to whatever BC equals. That's your equation. A lot of you are still struggling to write the equations. You can just learn how to say it in words. I know this side is equal to this side. Well, is equal means you're putting that in between. All right. Solving it out, you'd subtract 4x from both sides. I would subtract 4x from both sides. It would work if you subtract. Do not combine it into 9x. A lot of people still doing that on the quizzes. You've got to get rid of the variables on one side. If you need to write that note down every time I say it, write it down. So x subtract 6 is 5. Now to get rid of the 6, you add 6 on both sides. And all, like I said, it's not really a proof. You're just solving for x. That just proves that number makes the legs equal. That's why they call it a proof. But all you're doing is really solving for what x has to be. So that's a pretty good example of a problem you'll see. And I consider that to be the easy problem on trapezoid. There wasn't anything super complex about that. All you had to know is that the two legs, once I tell you it's isosceles, you just had to know the two legs are congruent. Well, you know they're congruent. That just means you set the whatever the lengths of them are. If it's numbers in a variable, then you set the number equal to the variable. If it's expressions, you set both expressions equal to each other like this one, and then you have to solve. And remember, if we solve for it, make sure you go back and check, because it might say, what is the length of AD? And you would have to plug in the 11 and then say, okay, well, AD, the length of AD is actually 4 times 11 plus 5. I don't know why I wrote 6 plus 5, so 49. So the length of AD is 49. X is 11. Some of you missed out on the quizzes too. You're still not getting that X is only a part of the length. It's just, it's its own number. If there's an equation or really it's called an expression that represents the length, you got to plug that back in to find the length. Several people missed out on the last quiz too. All right. I want you to try to do part B. We're not going to probably do C together, but you can try to do it. You'd have to figure out. Actually, that's a pretty tough one. You'd have to do A. I think you'd have to do A squared, B squared, C squared, and C. But you should be able to do this one. You should know what the theorems say about degrees. I'm sorry, about the angles of an isosceles trapezoid. Some of them are equal, some of them are not. So you should be able to figure out. And again, this, I haven't looked at the next quiz, but I'm pretty sure there's one just like this on the next quiz too. Actually, one of these is your exit ticket. You'll do an exit ticket on Thursday. It'll be one of these two, probably. It's pretty simple, but yet it'll tell me you understand basically the definition and maybe the theorem of isosceles. Say it again. Yeah, you're using the same figure. Yep. I didn't copy all the stuff down in between. I just typed it in, but yeah, we're still doing the same problem. This is just, instead of doing sides of that guitar, we're doing angles of the guitar. Oh man, that stinks. Oh. Give you another minute, then I'll probably give you a hint. I remember when. 8. So what angle is congruent to C? That's the first thing you need. It's not it. You went there. I'm pretty sure it wasn't it. Which angle is congruent to C? Like, I don't have the figure up. You can look at it in your book. I'm sorry. Yeah. Which angle is congruent to C? Where we end off? So red one's out. Mila. Which angle is congruent to C? This is one of your theorems. You need to know based on the theorems. I mean, kind of definition kind of thing. Which one? Say, I mean, well, yeah, I don't need to know the theorem, just which angle is congruent to C. Believe that's correct. All right. Yeah. So if D is congruent, actually here, I'm just going to kind of draw the guitar in. So that side, that side, that side, that's. All right. So that's my guitar. I think it goes like this, A, B, C, D, right? So if I know this is parallel, then I know the top and the bottom of the legs, kind of went over that. The bases, we said it's the angles at the ends of the bases that are congruent. So C is at the end of one of the bases, right? Because the bases are the parallel lines. Well, the angles at the end of each base are the congruent. So that means if this is 72, that is 72. Now here's the tricky part. That's the easy part. It won't be that easy even on the exit ticket. How in the world do I find A? And you're up anyway, baby. No, because diagonal line doesn't really do us any good because that's talking about the lengths of diagonals. And it's not a parallelogram, so you can't just say opposite sides or what. This one's a little trickier. Do we know that they equal 180? Like there's no theorem that says consecutive side. That's a parallelogram where they equal 180. So we can't use 180. So again, you got to be. But what do we know? We started this lesson. I said, what do you know about any trapezoid, even if it's not isosceles? What do we know even about a trapezoid that's got a weirder shape? What do we know about that trapezoid? Interior angles are what? So we do know what all the interior angles have to add up to be, right? So now I want you to see if you can figure it out, if you couldn't already. That's the piece that you need to connect in order to finish. So now I'll let you try to finish it out. There's another thing I'll just kind of tell you again, angles at the base of the leg, I'm sorry, angles at the end points of those base sides are congruent. So that means those two are congruent also. Did you do this one? Did you ever get it? I'll give you another minute. I gotta get one back. We have to do kites too. God damn it. Why does it stop writing? Right out of me.
What were markers right there?
Yeah, but I don't want it to wipe off. This won't wipe off. Yeah, if I bump into this with anything, the whiteboard. Yeah.
Where's my name?
Oh, you didn't get your birthday thing yesterday. Remember today, and also I have. I didn't give it to you yesterday. I think I have Takis and burritos for sure. Maybe some. Candyland. I think it's like burritos.
I don't like.
Pretty sure I don't need it. Not a big spicy.
Like just certain things. I like spicy stuff, but like Takis are kind of the wrong spicy.
Yeah, no, I will say I can eat 2 or 3 Takis and be okay.
Yeah.
I don't mind the taste of them, but I can't do much more than that. All right, so what is the first equation, or what's the next thing we could do? Where did I leave off? And how? What's what's an equation we could set up, even if we can't solve it? Given what we just said about any four-sided figure. No, does 72 equal 360? Think about this. What is true about a quadrilateral, any four-sided figure in the angles? So say it in words. So what's true? Say it again. We got to get this down. If you can say it in words, you can create an equation. No, say it in words. Any quadrilateral. Don't worry about this. No, but any. This one is true of anyone. No, that's fine. Trying to get four angle. There. It's true of that one. That one has zero properties. But this is true for that. There's no parallel lines. There's nothing congruent. But what is true about that figure? They add up to three. What adds up to 360? That's the part you have to say out loud. No. Angles. Sides can be anything. You can never say sides always add up to something, because I could make that twice as big and now sides don't add up to a number. But the angles don't change as you make the shape bigger or smaller. So here's what I was trying to get you to say. The angles, that, circle them. I'm giving you processes and you guys aren't using them. I can't hold your hand. You have got to do this. Write it down. Circle the angles. That angle plus that angle plus that angle plus that angle equals 360. It's the same for every problem you're ever going to do with four sides. You may have different information given to you, and you may have to make another connection, like with an isosceles trapezoid, but that angle plus that angle plus that angle plus that angle has to be 360. It will never, ever change the angles unless you have more sides. So don't I know something about some of those angles I just circled? Where did I leave off? Rihanna. Oh, no. Yeah, Rihanna. What do I know about, again, I just circled the angles in blue. What do I know about some of those angles? Look in the circles. What's in some of the circles? Again. Well, no, just what's in the circles. What do I know? Look in the circles. Yeah, look in the blue circles. And I'm talking about the red figure, not the green figure. So what's in the circle? So what's in the circle? Those are the angles, but I know more. Like here, there's nothing in the circles, right? I got no information. I've got information in a couple of those circles in those red figure. Yes, that's again, that's the process. Whatever you circled, whether it's 2x plus 4, whether it's 12, whether it's 30, whatever is in that circle is the measure of the angle. So I know that those four angles have to add up to 360. I don't know what's in the other circle, but what do I know about the other circles? Even though there's not a number, there is some information in there. What is true about these two angles here in that circle, even though I don't know numbers? What's true about them? Hey, what's true about them? They're the same, right? So I don't know the number. Why it's a variable, but I do know it's got to be the same number. So that's your, and then equals 360 is your equation. So that's, guarantee you that's a question either on the exit ticket or the quiz function. And that's not a hard one. It's going to get tougher than that. You need to know how to do that. So I take that, I add the x's together, 2x plus 144 equals 360. I'm not going to solve it. You need to be able to do that algebra on your own. We got to get, I'm going way too slow. All right, so quadrilateral QRST. I'm not doing a whole lot with this. I'm really just reminding you, what did we say we use or we typically are going to do when we're dealing with a coordinate plane? What's the one measure we typically are going to use? We've said it many times. We could use slope, we could. So if we needed to figure out which lines are parallel, because there are going to be, if it's a trapezoid, there are going to be some parallel lines. So we could use slope. There's another one though, which is main one I was thinking of. What else can we tell? Distance, perfect. Yeah, again, write it down. You couldn't answer that, write it down. If you have a figure on a coordinate plane, there's a really good chance you're using a distance formula. Or somehow you're gonna, because we can't figure anything about degrees. We can't figure anything about the angles if all we have is a shape on a coordinate plane. We only have one thing we can really do, and that's figure out the lengths of the side using the distance formula. We could figure out slope like we did in the other problem. So if that comes into play and you need to, if we needed to just prove it was a trapezoid, we might use slope to prove the opposite of two sides are parallel, because we could do it using slope. But they already told us that. So really what we're basically doing is we're trying to figure out, are two of the sides congruent? And if they are congruent, then it's as if they're opposite sides, then it's isosceles each other. Mostly. So that's all I'm going to tell you on that. Just again, reminding you that's distance formula. All right, so here's a new one. I'm going through this one super fast. There's a proof to it, but it's not an easy proof to even just like conceptually understand. Like it's easier to just probably intuitively make the best guess on it. If I have what's called a mid segment, UR is the mid, so you need to know the definition of this. And that's really about all. Just this is probably one you'll memorize for sure, no matter what. And it's not that hard to memorize because it kind of just makes sense. If I have a mid segment, what that means is the end points of that segment, again, the end points of UR. So U and R basically. U is a point, R is a point. UR is the segment. The end points are the midpoint of the leg. That's what these are telling you. That point right there is the midpoint because it splits that side into two equal segments. This point right here is the midpoint of that side. It splits it into two equal segments. So that's the first thing you need to remember. If I tell you, and again, I will not give you this. You will not have the congruence mark. I'll just tell you UR is the mid segment. And then I'll say solve for something. So you have to understand by telling you it's the mid segment, that also tells you that it splits the legs, will always be the legs. It splits the legs in half. These are midpoints. So you got a mid segment and a midpoint. So the other thing you need to understand is the length. So write this one down. Actually, that's probably the theorem. So, it's parallel. So you do need to know that. If that's not obvious to you, this is going to be parallel to the bases, and the bases have to be parallel because that's the definition. So it is parallel. That's the only way it could split both sides exactly in half is if it's parallel. If it got twisted at all, it's not going to split both sides in half. Yeah, got to be parallel. Yeah. So here's the big one. The length. So I'm going to write it a little differently. The length, I'm going to kind of make it a formula, of the mid segment equals base 1 plus base 2. So again, bases are the parallel sides divided by 2. And sometimes they're not going to give you one of the bases. Like they'll give you the mid segment and one of the bases, and you have to figure out the other base. That's the other type of problem, which same formula, you just solve it differently. We'll probably do one of those. So again, all I would do is say 11 plus 18, divide that by 2. What's that? 29 divided by 2, so 14 and a half. Should have been the answer to 3. Fine, do the check really quick. So try to do the check problem. We just did that one already. There's not much to it. Again, just make sure you understand. I mean, you can, it's just like, I'm hoping it's just intuitive, so I'm not spending much time on it. If the mid segment is between those two numbers, then the length of it has to be between these two numbers. So when we go to solve for one of the bases, you need to adjust that and say, okay, well, if the mid segment is between them, then the other side, the other base, has to be either bigger or smaller or something like that, whatever. We're going to do one of those. I'm going to spend a minute on that. Not spending any time on that.
If you come up with a number of 30, you know that that's totally off base because it doesn't
Yeah.
fit in.
Yeah, if you forget to divide by 2, for example, and you come up with 29, you should know automatically it can't. I mean, just look at it visually. That now there won't always be a figure possibly, but if you have a figure, even if it's not perfectly to scale, there's no way that middle line could be longer than the bottom side or shorter than the top side. Got it all? All right, so again, try to do the check real quick. Shouldn't take you a real long time. And the key to this is that they did not tell you. Actually, no, oh, this is for any trapezoid, not just isosceles. So write that down too. I didn't really emphasize that, but if you'll notice, it doesn't say anything about an isosceles trapezoid. This is its own thing for any trapezoid. Make sure you make that in a big note. Mid-segment works for any trapezoid. All it has to be true basically is the top and bottom are parallel, or the left and right. Any, yep, does not have to be isosceles. Because you can clearly see that's not isosceles triangle. The left and the right sides are definitely not the same length. And the angles are not the same. Angles, not the same measures. So if 23 is my number, 16 is my number, that length has to be right in the middle of those two. It's in the middle of the sides. That's why we split it in half. So the length is in the middle of those two. The concept. What'd you get? Sounds like to be right. And again, that makes sense. Here's the other check you can do. If that's 19.5, how far away from 16 is 19.5? Like length, how much longer is 19.5 than 16? 3.5 longer, right? So the length, the difference is 3.5 between those two. Well, what's the difference between 23 and 19.5? 3.5, right? You should always get that quick check. You should always have the same, because it's in the middle, right? The length is the average in the middle. That's what average is, right in the middle. I want to do one there. All right, so here's the trickier version. I wanted to spend a little. So 24 is that. If it's in the middle, then it's if the number is in the middle, and again, no degree symbol, so it's not about degrees inside the figure. The 24 is about that. We know the 16 is about that. I need to know what is the top base. What would your estimate be? Before we even do any math, what would you just guess? Keep in mind, this number has to be in the middle of whatever the top and bottom numbers line up being. Quick guess. Who am I going to call on? Jamarcus. Quick guess. 24 is the mid segment. I'm trying to find out the top number. What's a quick guess? If 24 has to be in the middle of the top and the bottom number. Once I figure out the top number. The 30s. Yeah, I would say if this just quick math tells me, well, that's about 8, not quite 8. So I'd have to add about 8, which means it'd be just over 30. So now see if you can do the math with that equation. It's the same equation, nothing changes. You just have information in a different spot. So length, I'm going to shorten it up a little bit. Length of the mid segment equals base 1 plus base 2 divided by 2. But in this case, I don't know the two bases. So we need to fill in different information. What's the length of the mid segment? Because I know that in this. So I would write, so again, I'm just taking that and rewriting it over here with the numbers. So I would write it like that. Instead of adding the two numbers, just be careful because a lot of you are just going to add two numbers and divide by 2. That's not always the way you do it. It depends on what you're solving for. And it doesn't really matter which one is base 1 or base 2. What's base 1 you want to say? I heard 2 people. I'm going to say X. I heard X first. What's base 2 then? If that's base 1, yeah, it's the other side that's parallel. So 16.7. So that's your equation. Again, if you can just do that and you can't solve it, I get you to a C for that problem already. For that problem. Now, how would we solve? That's the lab. This is the algebra part that you got to practice. Oh, that's easy. Do what?
First, you would divide. Oh, no, you would
Divide.
multiply 24 by 2, and then you would
So-
add 16.7 to the 24 on here. Or what?
If I am solving for a variable, nothing ever changes from the fact that I'm just trying to get the variable by itself.
Yeah,
I need to get rid of this, and I need to get rid of this. You got a 50-50 chance, but hopefully, I try to like subtract 16.7, I can't subtract 16.7 because this is actually 16.7 over 2 and X. Like,
so
hopefully you see that you don't do that number first. So I need to get rid of the 2 first. What's the math going on right here? What's that math? What's
it's
this?
division.
So we do the opposite math to get rid of the 2. Always opposite. So times 2 will get rid of it. So that gets rid of it by doing the opposite math. Well, then I need to do times 2 here. Now I have X plus 16.7. Well, now should be pretty obvious how you get rid of the 16.7. What do? And that's your answer. Yeah, what is the final answer? And if you really want to make sure, just add the top and bottom together and divide by 2, and you better get 24. Just a quick check to make sure. Same thing down here. I'm just showing this. Oh, I do want to show you one thing. If you get a problem on the coordinate plane and you're like, I have no idea how to do that. If you can just remember the concept of mid-segment, what does a mid-segment do to the 2 sides, the 2 legs? It bisects, it splits them in half. It's the midpoint, right, of those segments. If you can just find the 2 midpoints of those segments, and then connect them, that's your, like there, you don't need to do distance, you don't need to slope, which is actually the way you would solve it, is using those. That's a shortcut that will work a lot of the times on your EOC, your district tests, mostly EOC. So if I know that's 1, 2, 3, 4, 5, 6, 7, 8, 9, what would I do to split 9 in half? How far would I go? 4.5, right? You just divide by 2. Anytime you're splitting something in half, you divide by 2. So I would go here, 1, 2, 3, 4, and then I'd go 1/2. So there's my point. What point would that be? What's my ordered pair of X and Y? Who am I calling that? Chloe, what's my X and Y? You hopefully see it. X comes from here, Y comes from there. And the Y doesn't actually change. And it goes by 2, so be careful. So that's one of my midpoints. So now the other midpoint's a little tougher because we're not just counting left and right. But again, if you don't know how to do the math and do it the more complex way, there's a pretty good chance the midpoint is going to land right on corners of squares so that you can use an X and a Y that's really easy to see. So that's a big hint. Where would you say, and you can look in your book if you want, where would you say along here, again, thinking about it landing right on that, what might be the midpoint? Halfway and it lands right on corner of the squares. I would say that looks pretty good to me, right? Looks like it's about halfway. It's the only point, and I mean, none of the other point. Well, maybe you could say that one kind of does, but clearly that's not the midpoint. So I'd say there's a pretty good chance that that's the midpoint. I could even confirm that by doing this. If I go, and again, this is a half, just keep in mind, half, 1, 2, 3, 4, right? Well, that's 4.5, and that's 2. I better have those same exact numbers going to the other side if it's the midpoint, because the distance I travel needs to be the same, even if I'm going left and right and up and down. Well, let's see, 1, 2, 3, 4, and then about a half. Oh, wait, I'm sorry. Actually not.
That's like 1/4. No, 3/4.
Yeah, that we might be wrong. That's not the midpoint. 1, 2, 3, 4. So actually that's 5 and then 2. So it's really not the midpoint. So that wouldn't be the midpoint. So again, it'll at least tell you that that's not the midpoint doing that. Now we're close. We're super, super close. So my guess is on this one, it's not going to come out and be a nice round integer. But which direction? If we went 5 here, so this is 5, this is 4.5, we'll say. We're guessing kind of. Which direction would I need to slide this point to make it the midpoint? Well, just right or left. Like if this is 4.5 and that's 5, which way would it need to slide? Right. Need to go right, right? Because this is too long. This is shorter, and I need to make them the same length. So I need to make this a little longer and this a little shorter. So our midpoint's actually going to be a little over 10. Still would have to be probably around 2. So again, if it's an EOC, it's multiple choice, right? So just look for the value when you haven't really done any math at all yet. So not taking you a whole long time to get here. Look for something that's like 10.1 or 2. They say 11. Well, 11 would be more in the middle. I'd say maybe it's going to be like 10.2. And again, the only way you'd be able to get it right is it, and I do believe the EOC is practically all multiple choice, and they're not going to give you 2 values that I think are super, super close together. So 10.2 and then somewhere around 2-ish would be what you'd look for in the multiple choice answer. So again, if you can do the math, I mean, it has to do with doing distance formula stuff and figuring out you'd have to figure out the slope going from this midpoint down to that side. Like you have to use the same slope and figure it out. It would be very complex, and I don't even know that I would recommend you try it because there's so many places you can make a mistake. I would do the eyeball it way and then move on to other problems on the EOC. But don't just give up. And there's some ways you can make a better educated guess for sure, because some of the answers are going to be way off. I guarantee you there's going to be 2 answers that you can be like, well, yeah, that's way off if you just go through this process. If you can narrow everything down to 2 possible choices on an EOC, you will pass an EOC. All right. Boy, I'm way behind. Kind of the same thing, find the endpoints. You'd have to go through that same process. I will say this one's easier. 1, 2, 1, 1, 2, 1. That's definitely the midpoint there. 1, 2, 3, 1.5. 1, 2, 3, 1.5. So I'm pretty sure that's the midpoint. So that one would have worked out, I'm pretty sure, and you would have been able to just do it like that and get the correct answer for that. Oh, wait, crap, I did that wrong. What did I do wrong? Yeah, you can't figure the midpoint of the bases out. It's gotta be the legs. That's totally wrong. But again, this is easy. 1, 2, 3, 4, 5. So that's definitely 2.5 because it goes vertical and horizontal. Now this one's easy too. 1, 2, 1. 1, 2, 1. So that's gonna be, so there you go. And if you really wanted to test it, that line right there going from that point to that point should be parallel. Back to the slope, Shandy. That should be parallel to the top and bottom lines. But those would be the endpoints of the thing. So there's other ways to do well on EOCs besides knowing how to do every single math problem on it. Just don't give up. And that's the same way on my quizzes. Don't give up, although that one. All right, here's the last piece. So turn to kites. There's not as much on kites. A couple of things you gotta memorize them. So a kite is exactly what it sounds like. It looks like a kite, like the old school, old-fashioned kites. Well, kind of like two triangles pushed together, two congruent, like the same triangle. So that's one of the first things. If I draw a line, that creates two congruent triangles. So the diagonals are perpendicular. Remember how I told you there's another shape we're going to learn that has that? The diagonals are perpendicular, and the diagonals also bisect each other. I told you that was going to be true for that shape also. Well, yeah, if they're perpendicular, that means there's 90 degrees. All four of those in the interior are 90 degrees. So that's your two new theorems. Oh, crap, forgot one thing. Oh, I'm sorry, they don't bisect here. I didn't mention that. Only one diagonal bisects. Right? So make sure you understand that. That's not really a theorem. The other thing is that there is exactly one pair. So again, not a parallelogram. With this, you got to keep this separate from parallelogram. Exactly one pair of opposite angles is congruent. So you should hopefully see this is not congruent to this. This angle down here is way skinnier. That angle is way skinnier than that angle. This one, however, is congruent. So here's the two things you got to remember. One diagonal, that's the line down the middle, bisects opposite angle. The other two angles are the congruent angles. And again, there's no parallel sides, like there's nothing parallel. So there's no, don't get that confused. Tarvis, Bud, I said phone earlier. They don't say everything I just said in those two theorems. There's only some pieces of that, but you need to study a little bit. The only piece they give you is this part in here. They're perpendicular, the diagonals are perpendicular, and they do tell you one pair of opposite sides is congruent, but you got to be able to figure out which, I'm sorry, opposite angle. You got to, oh, the sides, by the way, are congruent as well, these sides. So we're going to go through and do some problems with it, but can anybody explain to me? Let me get you a cleaner picture. So we have this figure. We've done this before. And I want to see who remembers their stuff. If I draw in two diagonals, those are perpendicular. We did something where you don't have to memorize anything if you just understand that these are perpendicular. There's another piece I can now add in, and there was a lesson we did on this. What lesson did we did that was really close to this? It was really the exact same thing. We created this before, and you didn't even know we created it. What did we do last semester? What did we do? Is actually technically it's still a quiz you can take. There are a bunch of congruent triangles, but what did we said, oh, how do I explain it without giving you a hint? It has to do with the fact that the diagonals are perpendicular. The word perpendicular is literally. I'm trying to do the same. What did we do? Something with perpendicular before. We used them to create something else. We created the circumcenter with it. How was the circumcenter created? It was in a triangle, but what was it? It was the midpoint, but there was a theorem that went around why it was the midpoint. Had to do with the perpendicular thing. We said if we have a right angle, right? Every point on this line, which we called that perpendicular bisector. Every point on a perpendicular bisector is going to be the same length from those two angles. So if this point K is on that, which it is, it's the same length from N as it is to F. If this point M is on that, which it is, it's the same length from N to L. So what else does that mean that I can add in? Here's the real. What else can I add in? One more congruence thing I could add in. You can just probably look at it and see. Yes. Use letters. Let me write a letter for you. O. We'll make that O. Use letters so I know which one. What's true about there's two more segments that are congruent. And what? Do you think that's congruent to something? That looks pretty long to me. What about that point right there? What's true about that point? Is it on the perpendicular bisector? Is it on KM? It is, right? Every point on KM is the same distance. Melanin. So we did that before. That was your perpendicular bisector lesson. Every point on a perpendicular bisector, which it tells us they're at 90 degrees. It doesn't really tell us that it's, I mean, it does tell us it's a bisector by telling us these things. So you'd have to be given some other information besides the fact that the lines are perpendicular. But they gave us enough. If we know this and this, then we can conclude that. That's the part you have to know, is that those are also congruent. Or I could have told you these are congruent and these are congruent, and you would have had to have known that those are congruent. So if I tell you two pieces of information, 90 degrees, and then these are congruent and these are congruent, or any two sides are congruent, you should know that the third segments, either where it would be these two, or these two, the third segments have to be congruent because of the definition of that. And I know that goes way back, but here's the thing. You can just memorize it. If you understand all of that, you don't have to memorize. If you don't understand that, then you need to memorize what happens here. And you need to memorize that that means all of those things are congruent. All of those sides are congruent in that picture. It really will never be these two that are congruent, because then it would be a rhombus. We wouldn't really call it a cut. Well, I know that was a lot. It's recorded. You're going to do practice problems on it. And hopefully next class we'll have, because that was really the whole lesson. Probably next class we're going to do a review and then a bunch of practice. And you can practice and you'll have an exit. Oh, the exit ticket again, just to remind you, was on the beginning stuff. This definitely not be it. So back when I told you when we did, what was first shape? Trapezoid. So that trapezoid, it'll be an easy one. You just have to understand if I tell you it's isosceles, you got to understand which angles are congruent, which sides are congruent, and be able to calculate out some simple algebra from that.
Oh, We're gonna tour out more pages, right?
No, we haven't for any yet.
Okay.
Oh, yeah, we'll probably do that Monday before your quiz or something. We won't need them this week. So, you do need to make sure you understand those are congruent, which angles are congruent in a kite. Because that can be tricky sometimes. Sometimes kids want to make, even though they don't really look like it if you're very visual. Sometimes kids make the wrong angles congruent. There's only one pair that's congruent, one opposite pair that's congruent in a kite. Why don't you try to do the check? I want you to find that angle. Let's put an X there. X degrees, remember? It's about an angle, it's about degrees. So you see degree symbols and you know it's about an angle. That's the check problem. We kind of skipped the example, but they did don't forget it's a four-sided figure, which means the total of the interior is 360. That can come into play with kites as well as trapezoids. So if I know there's four sides, I know the total interior is 360. And there's one other concept you need to get next, but we just learned. And make sure you are here Friday for your easy exit ticket, and then that'll be a big practice day for Monday. I might possibly even give you a freebie retake. I'll let you know that on Thursday. If you're gonna get a freebie retake on the Monday quiz. I'm pretty sure I'm going to. You have to see how many, because I don't need to put tons of questions on just kites and trapezoids. Probably just 3 or 4 questions on that. So I'll make it probably a 6-question quiz, and you'll get one freebie retake. I'll tell you which one it'll be. The other quizzes were 4 questions. I'll narrow it down at the most 3, but maybe I can even get it down to 2. But it would be 2 of the harder questions. So. What is it we need? What concept do we need to know here about kites in order to solve this out? I'm calling somebody else. Let's go with Sade. Sade, what concept that we just learned do I need to apply to this problem? Be able to solve it. That's a good question. Might help us. I don't know. I'll be honest. I don't know if that could help us or not. Let's see. I wouldn't have said that because there's a faster way, but that might. So if I have 90 degrees, how would you do that? How would you do it? There's an easier way if you don't automatically. There is a way that you could probably do it. I want you, do you think, try to solve, if you think you can do that, because the other way, some of you I think have already gotten.
Supposed to be solving.
F. There is a way to solve for F using that. That's way more complex, but it's kind of, it would be a good exercise for you to go through and try to figure out if the other one's super easy.
Yeah, I get it.
But let's just do the easy version then, because we want to solve for F and there's an easy version. What do we know about kites? Look up the kites. There's 2 theorems. Use one of them.
Oh, no.
Did you already use the 90 degree? So what? Look it up. You got it right there, girl. There's 2 theorems. Which one do we need? It's first of all, what is it about? What are we solving for? Solving for a what? Angle, right? So it's nothing about the sides. So the fact that the sides are congruent doesn't no other than it tells us it's a kite. Well, we already knew it was a kite. They told us that right there. So the sides don't do us any good. So there's got to be some theorem about angles. That's the one you need. So now you got to tell me which 2 angles, and it's got to be opposite angles. Which 2 angles are congruent in this figure? Opposite. So 128 equals 72. No. Come on. Has to be, yeah, if they give you numbers, it should be easy. They give you numbers and the numbers aren't the same, then those aren't the congruent. So we know angle F equals angle H, measure of it technically. What else do we know? That's the other thing we need. That goes back to just quadrilaterals. The angles total 360. We did one earlier, sort of like this, when we did trapezoid, I think. But you're gonna see this repeated a lot. Plus, and then we'll make the other two just X, because they're the same. So again, you get that same or a very similar equation. I think in the isosceles trapezoid, this was the same number. That was what you had to be able to figure out that. Here, you don't even need to know how to do that. You just need to know that all four of the interior, circle them if you need to. And be an X also. Those four angles have to add up to 360. Well, those four angles have to add up to 360 to make that equation. Did you do the 90-degree one?
Yeah.
I'll let you walk me through it while they're doing it.
I'm gonna ask you if this was right.
Well, walk me through it and I'll help you.
Oh,
Say something we can.
well,
We know this, so I'll give you a hint. Or not hint, but I'll write that in for
well, I
you.
already know that.
So we know that. So we know we got one 90-degree angle.
For G and J, you would have to divide it by 2.
Perfect. So I'm gonna do that on the left-hand side. So it's at 64.
64.
So I got a 64 and a 90. So 36.
At 90 degrees. Or,
Well, let me ask you this. Do you even need the 90 degrees now?
I mean, to find 180, since every triangle you pick 180, all you have to do is find the,
What do I have right there? Don't you know 2 of the 3? You just told me 2 of the 3 of them. We really didn't need the 90 that way.
oh, I did it,
Yeah, you could have, what you were doing will work, but there's the multiple. And again, I don't care how you solve it. That's why I say do what you know. Yeah. Do what you know, and you might solve it a different way than they wanted you to solve it. I don't care how you solve it. Yeah, so we could still use the 90, but I didn't even see this way until you started working on it. And then as you plugged in numbers, I was like, oh, wait, there's no way. So yeah, there's multiple ways to do a lot of these problems if you remember your past concepts. So that's why I say do what you know. Some of you did a pretty good job of that in the quiz, and it wound up getting you the passing grade. It's a little bit longer one, so get here fast, and yeah, you should. But it did take right at about, for some people, about 40 minutes. But you're a little faster. But yeah, get here right after the bell. Your course? I had to return them all. Yeah, if they were somebody that wasn't here, we had to return them. So yeah, go to the office for that. I'm not sure how to do that.
I have to ask, what's the big, record sign there for?
Remind me to record. Because I've tried everything.
Is it your-
I have tried everything with Tom. Well, you know, here's the funniest part of that story, right? Sleep. Yeah, it's gonna be a little warmer today, but not much warmer. I made this up, right? And I was just gonna use this and just like put it there or something. I made this up in this class. All right, I'll see you there. 3 o'clock out by, actually, I meant to have them announced. Just go straight to the football field.
After school?
Yeah, you don't have to go to that little field and we'll walk over. So if you see anybody, tell them, just go straight to the football field.
And Thursday?
Yeah, still 3 though, yeah. I was holding this in my hand for 20 minutes. And then went, oh crap, I forgot to record. Literally had that in my hand, big sign that said record, and I never started.
Oh, my.
That's why I did that. I'm like,
Yeah, that'll do it.
it's more for them,
Yeah.
because they see that and they're like, why is that there? I'm like, oh, that's right. Because I'll still forget what it
I
is.
like it.
Near the end of class, can you show me what I got in this?
Yes.
Also, can I retake that one on Thursday?
Yes.
Okay.
That's a long quiz though,
It is.
so
Yeah,
you need to get here immediately.
Okay.
Like when the bell, like Chelsea took it the other day. Did you finish that one you took the other, that Circum Center?
Yeah.
You did finish it, so, but it takes like, cause she's gonna come take it Thursday. It takes like pretty much all lunch, right? You would, would you say yes? No?
Yes.
I would say it did.
Okay.
Hey, what's up? What you got?
Yeah, I think that's in my picture. Yeah, I have those.
Yeah, she, we did several people. On it, we don't see them.
Well,
well, I don't think Isabella did it.
Oh, Chelsea. Did we dab? We took that, we did that, right? So, yeah, Janelle's got the pictures apparently. I think we took video of it, didn't we? I don't know what you guys did, but I know we went through the whole process, so I would imagine that was video, not. Let's see. What's the period? Ah,
Here, you want to see a photo?
my hand looks, my arm looks super long.
My arm's that long. This one is again,
I'd be good for sport.
but
What?
I just remake the leaf.
What do you say?
I just remake the leaf.
Sport?
Huh?
Another school?
Yeah.
You tell me you're doing that. Bunch of kids have done that this year. Tons and tons.
I'll think about it.
Oh, who was asking about taking that quiz? Oh, you,
Right?
Yeah.
so don't forget, there's one about like triangles too, like how to, what,
I didn't know.
how would you figure out, you know, what the possible lengths of a side are? And you did it right, but you gotta do it again.
Oh.
It's not corrections, it's just like a full test, so just remember that is also on there. Some people did.
So, yes.
Do the retake.
I didn't. Oh.
Hold on.
We talked about it tomorrow.
Okay.
Why is there stuff on our table?
Let's see. So here, this was one you had to do math on, you just, these are not the same length, I mean, look at that, that's not the same. Math, I'm pretty sure, well, it involved any good thing to be right angles, solve it out. This one, you just need to know what a pin center is, how it's created, where the congruence marks are. Study that. That one I actually threw out, but it's on the retake. Again, that's in centered, you know what's congruent, how to solve them. There are some right angles. So you need to know what it's an A squared, B squared, C squared thing or easier. I will see you in a little while. Here's another just congruence one. You just have to understand for circumcenter, what's congruent. It's really just side stuff. There's nothing, I mean, there are something. I gotta go here. Oh, yeah, you put these, or these are, so you did the same thing basically. You don't know. Make sure you understand it's not, you can't make everything. Yeah, then what is and what isn't. This one was the trickier one, altitudes. You need to know how to solve the length of the segments. If you have a problem where it says altitude. Well, actually,
Why
that's
miss I go?
central. Hi, man. So you are going where? So you don't know school. Oh, wow.
Warm in here?
Holy cow.
Ooh.
All right, we'll talk more about it. Again,
So cold
if
out
you
there.
have a centroid,
We did it.
we totally just did this.
No, we didn't, bro.
Oh, my God.
No, we did it.
So you need to know there's a relationship between those. And again, in center house. Oh, and then or the center house. period. All right. When are you taking it? Okay, yeah, we can. Let me put my work up and then,
Wait, what
God
test
dang
is
it.
this for? Mr. Yeah, what test is this for?